So, welcome to part 4. In the last part, we identified the false positives for labels in the extended memory area of 4000 to 7FFF, and we also identified the main other memory blocks, like the display list and the screen memory that I used. So, when we look at the area of 4000, then there is now a handful of labels still left. What's the reason for them? It's not strings. I converted all strings to string type, and they are listed as corresponding ASCII or ATASCII texts now in the source code. But let's look at this, for example. Here we have a command. Here we have a jump subroutine into the extended memory area where we know there can only be data. So this cannot be code. We see that there is a subroutine before it and the subroutine ends, and there is a subroutine after it. And between that, there is a jump subroutine and then a byte 00, which would be a break instruction and would crash the computer. So this is the default that DIS6502 assumes if it comes along this. So this assumes to be code, but we know when we look at it, no, this is not code. And when we look at the byte patterns, then we see this is 20604000. And for those who remember, we had the same thing in the bootloader. And when we do actually this, we will see that this is used here as an exclusive OR to convert something into the range of ASCII or screen code. Yeah, so ASCII and screen code is 128 bytes in sections of 32 characters. One is the special characters, one is the lowercase characters, one is the uppercase characters. So obviously something happens here and it divides the accumulator, transfers it to the X register, and then XORs something. So this is definitely not code, this is data. And by making this explicit and setting the corresponding type, we should now have one label less in the area of 4000. Let's continue with this one. Where is this used? Ooh, this is cool. Yeah, when you look at this, it is quite obvious that this is crap. Yeah, so this is interpreted as code, but it's not. There are lots of byte instructions that are no valid opcodes mixed in. There is a lot of indirect addressing that doesn't make sense. So this we have to tell the disassembler, sorry, but this is no code. And we see where this starts. It's actually quite a lot. Also from the memory area, we are below 3000. And if you remember from the memory map, we saw that this is used as a data area. So we can actually mark all of this. Starting at, where is this? 2E, yeah. All of this should be defaulted not to be code. Up to the screen RAM, which starts at 3C. Oops, I was too fast again. So everything up to here should not by default be interpreted as code, but as bytes. Now we see still two labels are left that point into this data area. So these could actually be correct labels. Let's look at these. But again, we see this is byte, byte, then an instruction, and then byte, byte again. So whatever this is, it is definitely not code. Maybe when I turn on screen display, KMGO. Yeah, it can be anything, but it's not code. So turn it into byte for now. And check. We got rid of the label. There's one more left. Yeah, again, this is obvious that this is not code. Yeah, byte, code, byte, something with an index. It is a clear indication. So we see this is byte. Check the labels again. It's gone. Here we have one left. Again, here the actual routine. There is an actual routine, jump subroutine followed by a jump. Coding ends, and then obviously some kind of data starts here. So we set this, all of this. Also these subtract statements, they are basically nonsense. And I see the pattern repeats with a F3, F5, AB, all of this. I set it to bytes for now. And then actual code starts again. So in the area of 3000, 2000, 3000, there is not much. This ASL definitely is not a assembler code. And also this is, again, you have always, and I will come to this later, you have always these ASCII tags, and then you have some data of which we don't yet know what it is, but I have an idea and I will tell you later. So we turn this into bytes, scroll back to 4000, 3000, 4000. So we see this is now all data, screen memory, something that's pointing directly into the screen memory with lots of crap around it. So let's see here, the routine ends with an RTS, and everything that's behind this RTS is mainly crap or data. There are zeros. So let's assume up to here it is probably just some data. This in theory could be something reasonable because here it looks like code. Yeah, but we'll leave it like this for the moment. Going back, checking for false positives. And you see there is not much left. There are just a few locations in the main area. Let's see. Again, this starts with a byte and then some code and byte. Definitely not real code. All of this, including the 0, cannot be real code. Oops, I was too fast. So let's start up here. Eight one, 8-1. You see the pattern there. There is always something 8-1, something 8-1, something 8-1. So let's do it up to here. And then it continues 8B up to this location. And then something that could, or looks like reasonable code, load something, flip the high byte, store it, jump somewhere. This looks like reasonable code. I think we are almost done with the false positives in the main memory area, in the extended memory area. So again, here we have coding. The coding ends at this location. RTS. Not sure how far that goes. This one could in theory be code. You see, I see it from the opcodes also, whether it gets a valid opcode or not. So, and this could be code. Yeah, actually we see there is JSR in another location that goes there, so that's not too unlikely to actually be code. And this A8 then is probably also code. Yeah, now it makes sense. The code makes sense. So here we have a table, And we see also there is one indexed access to that table, so that again makes sense. Scrolling up to my favorite 4000 area. Just a few to go. Here we have a jump to somewhere AO something. And then we have bytes that are obviously no code. So at least these two are no code. And once we turn him, this probably is also data, but I'm not 100% sure, so I leave it undefined for now. I just want to get rid of the clearly invalid labels. Yeah, these are nice patterns, but they are definitely no code. So all of this, including all these 9s and A. The A actually could be an ASL statement, so I changed this to byte. Yeah, see? And it is part of a code. So what's happening here, it is multiplying accumulator by 2, transfers it to the X register, and then use it as an index into a jump table. And that's what we are going to head for next, jump tables. So only 3 of them. Yeah, we are back to this location because after this code for the jump table, there's again lots of crap. Yeah, repetitive instructions, load, load, load for the accumulator. That wouldn't make any sense because it would override what it just did before. And ultimately here there could be some code. And that means that everything behind this RTS, where is this RTS? 76, this is AD, 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 AE, AE, AF. So we see all these repetitive patterns, at least up to here. So set them all to byte. And this at least could be some reasonable code. Maybe even the parts before now could be code. Yeah, they make up reasonable code. And these look like repetitive patterns for a jump table. We're heading for the finish in the extended memory area. Here again, routine ends, something strange starts, which definitely is no code. This could be code up to here. Set it to bytes. Then there's still some crap. So this probably is still no code. Yeah, you have to be careful not setting things to not being code. You should only do it if you're really sure, because if otherwise, if you miss out some labels or it's actually code, then it will break as soon as you later on change the origin of your program. Okay. 2 left, 3 left. Yeah, this could look like reasonable code, but again, in the middle you see some byte that cannot be assigned to code. Again, some bytes, so at least after this jump to this section here, I would turn it into bytes. And also this doesn't really make sense as code, but the next section does, because it just starts with a jump subroutine. Here we find a similar pattern again. We even find the string. Oh, I had missed that one. There is an error string. And after the error string there is some data. Don't know yet what kind of data that is. So we set it to code. And then something starts looking like code, but again we have right in the middle an undefined byte, so this is for sure also still no code. Oh, now I set it to code, I wanted to set it to byte. Ooh, still it doesn't end. All of this. All of this up to here is not really at least up to here something that's not something somebody would actually code. And these probably also not, but let's focus on the area we want to complete. This one is left. These are bytes. And the last label. Yeah, typical indication of not being real code. Yeah, overwriting the accumulator with something that happened just a line before. Something no programmer would do. And ultimately, all of the main memory area is clear. Main of the extended memory area is clear. Main program starts at 8000. Here we have a data area out of which we don't yet know what it is for. And we have some code, and still we have a number of strange data. Here we see P colon. That's of course some kind of printer. File specification, so which ends with an EOL 9B. So we should change that to a string. Yeah, and that concludes the part for now. We have eliminated all the false labels in the main memory part, and next is going to be jump tables.